Here's a Fender Deluxe Reverb. This particular one has been on my bench before for some other work. This is the shop amp, and basically it has been working fine since I worked on it about a year or so ago. And I am told that a couple weeks ago, in the middle of its use, there was a loud noise, and then one of the tubes got very hot. I believe one of the finals, 6v6, and the other tube, no temperature at all. And the amp was shut down and subsequently turned over to me. So this is not going to be a power on trial. We're going to break this down and we're going to find out what happened. So let's get started. Given the information that I had received about this amplifier and the fact that I previously worked on it, I decided that I was going to do a visual inspection in and around the tube socket, since that was already identified as the point of failure. It did not take long to find something amiss. You can see that this screen resistor is completely blown out, melted in the middle. You could see the brown across here on the bottom. It's all crunchy. This is definitely the point of failure. So I went and did a quick inspection here of the 4 resistors, right? And this is the other tube. That's the 470, that's looking good. There's the 1500, looking good. That tube socket is fine. On this side, we can see the 1500 is fine. Yeah, this one obviously, there's nothing. That resistor is blown out. Interesting resistor, this one here. You can see that this resistor connects to nothing but the tube as an endpoint on this side from the voltage provided right here. The only way for the tube to melt down like this is going to be caused by excessive current. I had been informed, however, that after this had failed, they had attempted to put in another tube into the amplifier and fire it back up again. Obviously it didn't work. So then they shut down the amp and they hadn't turned it back on. What I need is the first tube. I would like to check it out and see if there is a short in that tube, a physical short that would have caused this current flow, that would have caused this resistor to break. Now, this is not uncommon for this to happen on this amp, but if the plate voltage and the voltage coming off the rectifier, everything's on par, there's nothing crazy going on with the bias, everything is within specification. The fact that I had already replaced these resistors with these beefy resistors here, there should be no reason why that should blow out unless something like that happened, mechanical failure of the tube, which is why I would like to see the tube. That being said, I'm going to go and replace this because obviously this is broken. We're going to be going through all of the tubes for the amplifier. This is going to be the first project we're going to be using the Hickok 6000. We're going to start off with the rectifier. Like my other tube tester that tests everything in one shot, this one will be testing each plate individually. So we'll be setting up for plate 1 and then plate 2. What I like to do on these is just to make sure that they're both of these sides are operating good. I just look at the numbers and arbitrary value, but try to see that it's roughly the same. And this one I'm seeing, 2400, and this is also about 2350. So this is a strong rectifier. Both sides of the rectifier are just about identical in their emission. Next are going to be the 6v6s. These are the ones that I pulled from the amp. I've already been told that the tube that caused all the trouble that led to the amp ending up on my bench had already been replaced. So I'm only getting the replacement one, and whatever damage happened to that replacement one, I don't know which one it is. I'm sure it's going to reveal itself in testing. We'll get started. I'll point out that I have been given 6 tubes, brand new 6v6s, to go through and decide which one will match nicely to this amplifier. So this is more of just an academic exercise. If the short lights shut off, I don't even bother continuing the test. Tube's garbage. So I set up these things to read transconductance for these tubes right off the bat. I'm on the 6,000 scale, expecting 4,100. As I hit the button, we're definitely not seeing that. Looks like we're seeing just a hair over 2,000 micromos. So this tube is 2,000 of 4,100. This is garbage. I'm gonna pull this out. I don't make any adjustments except for the line test. And then I'm gonna put in the other one and I'm gonna see where that one sits. So this one's measuring just about 4,000 of 4,100. Of this tester, that's pretty good. That shows it to be pretty much on the money. The other one was showing 2,000. So this tube is good, the other tube is garbage. I'm gonna do an example of a 12AX7, and this has 2 triodes in it, so there are 2 test settings. We're looking at an expected value for these both sides for 1250. I'm seeing about 900. 900, I mean, it's not wonderful. We'll take a look at the other side, see what that has. This one here is showing just a hair under 1,000. So, yeah, I mean, tube's okay. I'll point out that on the other triode, the life test did fall into the gray area, which means, maybe this tube is ready to be swapped out. This one reads 1,100 on one side and 900 on the other. I wouldn't necessarily call them bad. This is just the reading I'm getting. If I were using a regular test set, I'm sure they'd all bounce, into good, but I'm just measuring it from transconductance. Testing these 12AT7s by comparison are ridiculous. This is a good or bad scale, right? And when I press it, we can see it is to the end of the chart, right? So if I go and set it up to read the actual value, that was a little bit high because of the line test, right? But if I get it up to right in a position and read the actual value, expecting 3,000, and I've said to the 6,000 chart, I'm reading 3,700. But then watch this, right? And this, I don't know, a 12AT7, right? But if I look right here, the original stamp on there, not the one from Groove Tubes, says 6201. With the 6201, I will come to find, obviously, as I would expect, that the switches are the same, but the bias is different. It's not 11, it's 14, and it's shunted differently, and the output is 3,600. So in actuality, the wrong information is on this tube, which I think is kind of garbage. Because if it's not a 12AT7, then don't stamp 12AT7 on these tubes. I think this is a load of crap anyway. But what I'm going to do is I'm going to retest this tube for what it actually is, a 6201. Let's see how close we get to these results now. Now I should be getting 3,600 on a brand new tube, and lo and behold, seeing 3,500. Why? Because I'm actually reading the correct model off the tube. I hate these restamps. These are stupid. Right, so let's look at the other side. We're seeing 3,500. Let's look at the other side of this tube. And this side shows a little bit weaker, is 3,300. But still, Groove Tubes. Get what you pay for. I've got what I believe to be a proper stamp 7025. We'll check that out. And this is showing 1,100 for 1,250. That seems plausible. That looks good. We'll go to the other side. The other side is showing 1,200 for 1,250. So yeah, this tube's good. Here's another mislabeled Groove Tube mess. 6201, garbage. This first side showing 31 of 36, and the second side is significantly worse. So this is 27 of 36. So this is probably not a good tube. Let's see how it looks like on the life test. Okay, it passes. This one says Sovtech 12AX7. I could only imagine, but okay, fine. I'm gonna set up for 12AX7. We're gonna throw it and see where it lands. Yeah, sure enough, this might actually be a 12AX7. This is 1,250, believe it or not, on the money. Other side also, 1,250. Exactly on the money, perfectly balanced. Who would have thought? But yeah, that concludes the tube testing for this unit, as these are going to be balanced later. We'll just replace this resistor right quick. So there we go, the new resistor is installed. We're gonna load it back up with tubes, and we're gonna check voltages as we bring it up on the Variac. I've got everything loaded up on the bottom as far as tubes go, except for the finals. I have all these 12AX7, 12AT7, 7025s, and the rectifier. I really just want to see the voltages coming off of the rectifier and the B+, but I want to load it down with these. Pulling about 30 watts right now. 117 volts. Everything's glowing real nicely. What I'm looking for right now is just simply some voltages coming off of the bias and the rectifier. Obviously there's no tubes in here for the finals. Yeah, so we're seeing 450, a little bit high, but again, it's not fully populated, so we should be seeing 415 fully populated. We're not seeing anything nuts though, and that's what's important, right? So standby is working nice. There we go. Now let's have a quick look at the bias, make sure the bias is functioning properly as well. Come off the center tap and see what the voltage is. Negative. We see a neg 33. If you were completely unaware of where to set it up, a starting point before you drop any tubes in would be neg 35, and then you would adjust, obviously based on current, right? So neg 33 tells me that nobody snuck in here with a screwdriver and did anything crazy or malicious, you know, or silly. I think it is safe now to drop some tubes in here, some 6V6s in, and we will retest. The one that measured 4,000 of 4,100, I'm going to put that one back in, and then I'm going to grab a tube at random from the new selection that was supplied for me. I'm going to match them later. I just don't want to put that 2,000 in. I simply don't trust it. I consider it damaged goods. If I'm going to put it in, I'm going to put it right in on the current meter immediately, see what we got going on, and see where it's been sitting. So I'm going to do that now. And these are RCA new old stock. The box says they were tested. This is September 52. Let's see what we got out of this. Okay, my meter is set up, though not visible on camera, but I could see it. Bias is still neg 33. Everything's fine. So now we're seeing 410. That is a reasonable number. Very nice indeed. And I am seeing the tube come up right now. 22.5 milliamps. A little cold. I will take a look at the other one. See how far off the other one is. I do want to give it a minute. I figured there was something funny. This was a tube that was in the amp before. That one, 22.6 milliamps. This one right here is showing 40. I figured there was something right. You know what? I'm not even going to continue testing with this other tube in there. I just want it out. So now I got the tester back on the other side. I've replaced that tube, and now I got them both running at around 40. I imagine the other one may have climbed. I'm not sure. All I know is it's not like 20 and 40 anymore, which is ridiculous. With that, before I do anything else, I'm going to back off on this. I want to get this at 35. This is a little hot for how they want it set up. There we go. So there's 35 idle current right there on those tubes, and if I get a nice match on them, they'll both be 35. Bob's your uncle. So, but the amp is running. I'm going to let this cook for a while under supervision. This other one reads about 33.2. It's just off by 1 milliamp, but I will go around and see if the other ones could match better because I have other ones. So here's the results of all the combinations of all the tubes tested against each other. And I ended up with these two right here. This is at the exact same input voltage on the Variac, measuring both the bias and the plate voltage to ensure that everything is consistent. I ended up with 32.8 and 33.1. That is just about as perfect as you can get for matching these without having a curve tracer, you know, based on the stuff that I have. Other ones were 16.5, 34.1, dead on arrival, and 22. So these are going to be the match set right here, and those are the ones in right now. And it is time to flip this over and start reassembly. And there we go, now it's all assembled. Let's test it out. Doing a quick diagnostic of the amp. Let's strum a few chords here. We got the reverb cranked up here on this one. So give it a little. Here we go, again. Nice. Now what we're gonna do is I'm gonna use the shorting plug for the vibrato. I'm not gonna use the foot pedal. So come back here. I got that in there. Let's dial it up. working good. Amp itself doesn't have any noise. It's nice and quiet. Pull the vibrato out. Yeah, seems to be working good. I hope you found the repair of this Deluxe Reverb amp helpful and enjoyable. Thanks for watching.